Okay, so before I do any more to this radio, I decided to hunt down the schematic for it, and that turned out to be a major effort. Because this radio is the Canadian version, which I don't know if it's any different at all from the American version. Looks exactly the same, but the identifier numbers on the radio here in Canada are different. So this is a number 409 Philco radio here in Canada. Can't find anything on the internet about that. Although in the long run, I did find a table that related Philco radios and their numbers in Canada to the alternate American number, and that's when I discovered that this is a 409 in Canada, but it's a 46-350 in the States, 46 being the year it was made. So I do have the schematic, and I'm going to run over it here and get myself familiar with it. Okay, so one of the things, first of all, I got this from Radio Museum, where I'm a member of Radio Museum, and there you see the number 46350. When I was on the site trying to select the schematic, well, there seemed to be three versions of the schematic on the website, all of them too small to really study and know what is what. So I picked one. I picked this one because it looked pretty good. And look at, we'll start off with this note down here. Philco Radio Model 46350. This material presented on this page was obtained from a sample receiver that was examined by the engineers of Supreme Publications. So in other words, some smart guys bought this radio, poked their way through it, and developed this diagram out of that. So that's kind of surprising to me. That must have been a pretty tough go, in fact, trying to do that. So this is not Philco's version of the schematic. This is another group's, Supreme Publications version of it. So we'll have to trust that they got it right. As far as I can see, it all matches my radio, but I haven't seen that far yet. So before we start going through the schematic, let's look at some other notes. Voltage measurements made with a 20,000 ohms per volt. That's a pretty good voltmeter. I had looked at the voltages here, 85, 80, 89. 9 and 67. Those are all pretty low, but then this is a tube, a combination battery plug-in radio. So under battery power, you don't get much more than 90 volts or so. In fact, you can anticipate the 95 volt battery depleting over time, and the radio having to operate with less and less voltage. So when they say 80 here, it's probably more like 70 to 90 or something of that sort. Although the 80 may come from operation with the power supply, like I'm going to do. So here's a note here. On some models, third pole omitted and wire used. Now, as schematics go, this one is actually really well drawn. May not be the neatest looking, and the writing work here isn't as good as it could be, but the schematic itself is exceptionally clear. And here's one of the reasons, which I don't think many people would pick up on. So see this wire here and how it's connected here. Is there any doubt that this wire connects here? Well, I don't think so. It has to connect there. If this wire were to continue up on the schematic, cross over and go somewhere, then at this point you could wonder, is this connected or is it just drawn crossing? Now if you look in this radio, a schematic, which I did, and don't look too close in case I'm wrong, I already see one that I'm wrong on, where the wire crosses, if it's connected, they've placed a big fat dot, and here it is right here. Big fat dot on there. Not many other dots used in this schematic. There's one over here. There's all these ones in here, but there's something else. This is a switch contact and stuff. But now I did notice here a wire crossing. Where did I see it? I saw it somewhere. See, normally they're doing this, right? They're looping over. Right here. So you see this spot? Now we're left wondering. I'm going to take it back about how fantastic this schematic was. So is that connected or not? They didn't loop it, and they didn't dot it. So I'll just put a mental question mark there. But that's the only one I found so far. Anyway, Most of them are T like this, where there is no doubt about the connection technique. So I like to dwell on schematics sometimes. But let's go through this guy now. We'll start on the power supply. So all this switching here is to switch between plugging it in and running a battery. I'm not going to study this. We're going to kind of skip over that. Oh, here's the battery plug down here. By the way, it's 2 or 3 batteries you're plugging into. A 90 volt battery and a 6 or 8 volt battery, or whatever it might be. Looks like a 9 volt battery. Anyway, back to the power supply. So power coming in here. Let's just see how this wire is treated. Okay, so I really didn't want to get into this switch here. Doesn't seem to go anywhere. It must go somewhere. So usually there's a note that says switch shown in so-and-so position. Let's see. Let's follow it back. So here's a battery wire. And see, it's open-ended. So the switch is in the AC position right now. In fact, you can kind of see that coming from the rectifier here. It's coming from the rectifier, not from the battery. Here we are here too. Here we are. And what's this guy? Is this the on-off switch? This might be the on-off switch right here. That's kind of, yeah, that could be. It's interrupting this power line completely. So somehow this heater gets its power. One side there, the other side beyond the switch. Yeah. So okay, so that's what this is. So it's probably switching the heater and switching the high voltage because of the battery arrangement. When you use the battery, it's like having 2 power supplies, so you need 2 switches. And the way they've done this, maybe they still need 2 switches even for operating from here. So what do we got for a power supply here? We've got 1, 2, 3 capacitors. Hey, no dot here again. No dot, no hop. I think we'd have to assume this is a connection point, especially here. Look, the guy wrote this number, 87 volts, and he drew an arrow to it. You think he'd say, better put a dot there. Well, so why did they bother with a dot here then? No, yeah, my opinion's going downhill rapidly. Who drew this? Who drew this? Bring him in my office. I want to talk to him. So, okay. So we got 90 volts coming right out of the rectifier here. It's going to drop on these resistors a bit, 87. So rather than using choke coils, they were using 2 resistors. This is actually a pretty good power supply here. Three stages of filtering. This last guy has to do with the cathode resistor, I'm pretty sure. Somehow, maybe not. Maybe not, eh? So the cathode, there is no cathode, so this looks like a directly heated cathode in the 3Q5. There is no cathode, so it's a heater. Okay, so you got me on this. So this will be a little more, it's going to be a little more tricky for me to sort out. We won't worry about it. Notice the 7 volts there, and the fact that the heater has a, wait a minute, I usually do this on the rectifier too. Maybe not with the heater running at 117 volts. What I'm muttering about without finishing my thoughts is how do they power the light? Well, wait a minute, they don't power the light. There is no light. There's no light in this radio. So I guess they're just showing you 7 volts here in case you're interested in testing it. It's the supply voltage to this. You know what? I don't know what this is. Yeah, I'm just going to have to shut up my mouth here at this point and just kind of walk away from this. You can see how they've shown the structure in here. It's a beam power tube, and they're showing the plates that form the beam here. That's why it has this funny structure in the tube. Okay, don't know why they bothered saying 7 volts there. Maybe there is a light. I'm just clued out. I don't think there is. Is there? The radio's right here. Why don't you take a look, Jim? No, no light. So let's start now. Let's look at the output. Speaker, how it's done. Okay, voice coil, speaker, output transformer, rather, that capacitor that's there in all radios that I don't fully understand why it's there yet. I mean, I can guess why it's there, but I don't know why it's there. important blocking capacitor here. There's nothing unusual about this radio, I don't think, really. So let's go to the antenna. Let's see. Well, this must be connect to chassis for loop operation. So these must be the two wires hanging out the back of this radio. Just taking a peek. Yeah. So it's showing a loop here. Where is that? Okay, that's interesting. I don't know where this loop is. It's on the inside of the cabinet, maybe. Let me just take a peek. Oh yeah, that's right. Yeah. It didn't look like a loop antenna to me. Oh yes, sure. The wires are out of sight. So yeah. So this is that loop antenna that's around the inside of the cabinet under the special protective tape. And we come down here. Connect the chassis for loop operation, which this is connected to the chassis right now. If you disconnect that, how exactly that is no longer a loop? Oh look, here's the grid. Here's the grid. Oh yeah, right through the transformer there. So I guess the signal developed in the antenna is then just passes through this coil to get to the grid. But if you want to stick an external antenna, I see, then you disconnect this from the chassis and hook your wire up to it, and then the wire is feeding this transformer then, which is then working against the grid here. So that's what's going on there. This is in a little can. That's why they've got the dotted lines here, or somehow it's shielded. 0.01. Maybe this 0.01 is out of sight, inside of a can. We can't see it. It's probably a paper capacitor. Okay, continue on up. Here's another big. Here's a big guy. 0.1. Down to the chassis through this coil. I think it's just trying to bleed out any RF that might be in the... Oh, wait a minute. I'll take that back. There's no cathode in any of these tubes. So these are all like 1 volt tubes. 1.4 volts, I think, is the actual voltage. And these are designed to draw the least amount of current, because after all, this is a battery operated radio, or can be operated by battery, and you can't be chewing away the amps if you want to run a battery operated radio. So then these tubes are selected, these 1 volt tubes or 1.4 volt tubes, because they're low draw. They're also instant on, by the way, because there's no cathode to heat up. So the moment you turn this guy on, this thing heats up a fraction of a second later, and the radio's operating right away, all the way through. No separate cathodes. Okay, now 85 volts. Look at all these tubes. These are all, look at, they've all got, they're not triodes, they're all pentodes. 1, 2, 3, 4, 5, I think so. Pentode. This is a heptode or something like that. Pentode. So the reason I'm pointing this out is that all these tubes have screen and suppressor grids in them, which I think alludes to the idea that these are better tube choices in making a radio. These tubes are really common in battery operated radios, really common. So I don't know that there was a large selection of tubes that an engineer could use to build a battery operated radio like this. Okay, so let's carry on. This guy's going to boost the signal. Oh, the signal's been tuned. Remember, there's a 3-part capacitor here. So this is C402. C402, C402, 402. Is there one more of those? 402s? 402. So 402, I think, is referring to the tuning capacitor. So you have 402A, 402, there's A, 402A. What? What? Well, maybe I got this wrong then. Maybe this is a part number, as in we order a C402 from Philco to replace your 402. That can't be the case. What is happening here? You know what they're not showing? They haven't got a gang indication where 3 of these capacitors are gang, but I mean we can bet. It's this one with its trimmer, this one with its trimmer, and this one with its trimmer. They're ganged together on the tuning knob. They didn't show it. So is there I'm looking at the capacitor now. You know, there's 3 trimmers on. There's a trimmer on each section of the capacitor. So these are right on the capacitor. Okay. Okay, good. So out comes the signal, nice and strong, meets up with this network here. I don't know exactly what they're trying to do. They're doing something. Tuning. So tuning in the antenna circuit, tuning after the RF stage before the mixer tube. So this is the add-in here that most radios don't have. Like, you know, a lot of radios don't have. I can just draw a line, chop all that off, and the antenna goes straight into the mixer tube. A lot of radios like that. So this extra stage here improved the operation of this radio tremendously. So, you know, look in and see a two section gang capacitor, 3 section, hey, 4 section, whoa! If you see a 4 section, whoa! That's got to be a big shortwave radio or something. Okay, so that'll get us through here to the next grid. So the mixer tube, so it's got 2 grids, this one here and this guy here on pin 4. This guy no doubt is picking up the oscillator from all this schmozzle here. And look at this guy, again, in a can or something like that, and this coil's not connected anywhere. It's like a little antenna. And where is it antennaing the signal? To the grid. Okay. So here we'll mix together the signal from the antenna, signal from a local oscillator, and a schmozzle goes out here, some of which will match or hit 265 kilocycles. These are all tuned to 265. Nothing unusual going on here. Goes into the IF amplifier. Out we go through another. Okay, there's some little bit of funny business in here. There's some funny business right here too. What's this doing here? So there's a coil here. I don't know why that's there. It doesn't appear to be, well, it's inside the can. I was going to say it doesn't appear to be connected here, or, you know, magnetically connected here, but maybe it is. You'd think they would have showed it like in line here. But for some reason this is in the can. It could be in the can to protect it from radiating out. You think, wow, this is sitting right here though. I don't know. Don't know why that's there. Again, this is probably a significantly important specialized feature that the Philco engineers had come up with. By doing this, there's some huge advantage. Beat the competition off. You can imagine it's true of all these things. It's true of automobiles too. The amount of engineering prowess which is pushed into these things, and then an ordinary consumer purchases them, and has no notion whatsoever of what people have gone through to make that item and produce it for them. You know, they go pick a car mostly by its color and how attractive the woman is standing next to it in the car ad. I feel sorry for the engineers whose brains must be split in half sometimes with the kinds of things they work on under pressure too. So okay, moving on. So here's the detector tube and audio amplifier, first audio amplifier tube. So here's the detector part right here. So you're feeding in the IF, it's going in here, it's getting rectified, it's going to produce a negative voltage here because of the way the choices made here. The negative voltage will be here. So this becomes the AVC voltage, or will be used as the AVC voltage. I already know that because I can see the wires heading down here, passing through this great big resistor. It's a great big resistor here. If we look this way, it's a pretty big resistor here too. even if we look past this capacitor, we see another really, really big resistor here, 4.7 meg. So what's going on here is the impedance of the actual diode circuit is low. So if you connect this, skip this resistor and connect it directly to the grid, which looks kind of indirect, but it does get there, you'll just snuff out the little signal that's reaching this grid through this capacitor. You'll snuff it out with a low impedance of the detector. So what they do is to protect the high impedance necessary on the grid circuits, they put this fat resistor in. There's almost no current flow, AVC current flow, or really, I guess you could pretty much say there's none. So whatever voltage is here doesn't drop across here, it shows up over here. So likewise, they don't want to, you know, like this volume control is heading for a grid. It's heading for the grid here. So again, the same problem. Except I guess when you put this all the way here, you get maximum volume. I don't know, maybe my story's not quite right. Hey, there's a 25,000 ohm resistor inside this box too. So, you know, that's another resistor. They're doing something fancy in here I haven't seen in other radios. So, all those Philco engineers. You know, for all we know, they stumbled on this by experimenting, just trying stuff, and found out, rather than, you know, using their brain power to come up with these. Who knows how they come up with this stuff? Okay, so where are we at? So we're looking at the AVC voltage. It's applied to the grid of this tube. Is that right? No. No. Let's follow the grid back. The grid goes back here. I'm looking for a DC circuit. Oh my gosh, go through here, up through here, and around through there, back through here. Oh, bang into this capacitor. So I don't think there's any DC circuit. So the grid bias here is probably controlled by grid leak. I'm not sure how it's done. You don't need much bias here. The signal level coming in from the antenna is going to be part of a volt, a minor part of a volt. So you don't need much bias to lift it and to keep the grid from going positive. And that's what's happening. So the AVC then is limited to this guy. This. What about this one? Typically, he gets a little AVC shot too. Oh. No, he's coming off of here. And this is just it's just a ground basically, I think. Don't quote me on that, but something like a ground. There's no AVC going up through here. So there's no AVC on this? Really? Let's just be absolutely sure. What's this little sneaky thing going on here? Far side of the volume control. Can't imagine that's AVC of any sort. So it could be the 1T4 is not a good tube for varying its amplification by varying the grid bias. And this is the only tube that really will do it. So this is the one they're concentrating on, the 1R5. To control the gain through here. Just beware, I can get a lot of this wrong. Okay, so we go through this fancied up deal here, but for the most part we're just bringing 265 kilohertz over here, rectifying it like I said. Now the audio is also on this line. Goes through the volume control, peeled off, some of it goes to the grid, amplified, shot over to the grid and out to the speaker. And a lot of fancy little Deweys in here, resistors and stuff. So that's the grid leak resistor there, the 2.2 meg. 1 meg. This is really unusual, I think. 9 volts is really low. Often the detector tube has a very low voltage on the plate. Wow, 9 volts. That's not a lot. Okay, so I think that's the story. So this is basically a very straightforward receiver, a high quality type because of the specialized front end and extra tuning stage in here, and extra tube at the front. So, and my understanding in reading a little bit about this is they made 1 billion of these radios. These were super popular radios, apparently, and considered very good quality. But I'm not sure I'm going to get too much more out of looking at the schematic at this point. Okay, that's great.